Hi guys, let's not got this test 14 review. First part says find the exact values of sine 2 theta, cosine 2 theta, and tangent 2 theta. So I'm looking at my identity page for the double angles and found them. First of all, I cannot do 1 or 2 without knowing sine and cosine. So because it says sine is 5/13, don't forget one of the famous triangles is 5, 12, 13, which means cosine has got to be, cosine theta is going to be 12, 13. So if you don't know that, you could do r squared equals square root of x squared plus y squared and find it that way. Did that in class today, so I'm not going to show you that again. But anyway, let's find these things. Sine 2 theta. So I'm looking up sine 2 theta on my sheet on the double angle formulas. I'm seeing 2 sine x cosine x is what it says. So I'm just going to plug the numbers in there. I'm going to say 2 times sine x is 5/13, cosine is 12/13. If I multiply all those out, I'm going to get 169, 13 times 13 on the bottom, and 120 on my numerator, so 120 over 169. Cosine 2 theta, you have 3 options on your sheet. You can use any of them that you want to. I'm going to go ahead and just do the first one, cosine squared minus sine squared. Doesn't matter which one you pick. Cosine squared is going to be 144 over 169. That's 12/13 squared. 5/13 squared is 25 over 169. If I subtract those two, I get 119 over 169. And then tangent 2 theta, I'm not going to work that one out. Don't need to. Remember, tangent, sine over cosine. So if I put the first answer right here over the second answer right here, the 169s would cancel, and I'll get 120 over 119. And that's that. Number 2, same type thing. This time they gave me cosine, so I got to find sine before I can do anything. Also realize I'm in quadrant 3, which means sine's going to be negative. It says cosine is 4/5. Remember, the most famous triangle is 3, 4, 5. So that means sine's going to be negative 3/5. So I'm doing the exact same work I just did. So I'm going to start with sine 2 theta. I'm going to do 2 sine x cosine x. So I'm going 2 times negative 3/5 times negative 4/5. If I do 5 times 5 on the bottom is 25. Also got 2 negatives, so it's going to become positive. And if I multiply the numerators, I get 24. Cosine 2 theta. I'll do a different one this time just to be different. So I'm doing 2 cosine squared x minus 1. Again, you got 3 options there. So if I square cosine, I would get 16/25 minus 1. 2 times 16 is 32/25. And don't forget 1 is really 25/25. That gives me 7/25. And then tangent 2 theta. Remember sine over cosine. So I'm going to have 24 over 7 because the 25s would cancel. Hope that makes sense. Number 3, use the half angle identity to figure out this one. Okay, so half angle, find that on your sheet. All right, and 67.5 is half of 135. So I'm looking at cosine x over 2 on my half angle identity. I'm getting plus or minus. I see plus or minus. Well, let's do this first. It's going to be 67.5 is half of 135. So I'm going to do 135 over 2. Because 135 is one that we know is on our unit circle. So I'm going plus or minus square root 1 plus cosine 135 over 2. And the plus or minus part, because I'm in quadrant 1 right here, I know it's positive, so I'm going to drop the plus or minus. This is plus. Cosine of 135, you can find that on your unit circle. Negative square root 2 over 2, all over 2. And that'd be done, except I need to get rid of the fraction and fraction. I'm going to multiply the whole top and the whole bottom by 2. I'm getting the square root of 2 minus the square root of 2 over 4. And I can't do anything with the numerator, but I do know the square root of the bottom is 2. So I'm going to leave it just like that. Kind of a weird looking answer, but not that bad. All right, number 4 and 5. Find an equivalent expression for each of the following. It's cosecant addition and then cotangent addition. So what I'm looking for in my paper is, there's not going to be a cosecant addition, sum or difference, but there is going to be a sine. So I'm looking for sine of x plus y on my identity page. So I'm actually going to work that out. I'm actually going to work out sine of x plus power 2. What I'm going to do at the end is just do reciprocal of my answer because sine and cosecant are reciprocal. So I'm following the identity. It says sine x cosine y. Y in this case is the power 2 plus cosine x sine y, which is power 2. Sine x cosine power 2, you can look at your unit circle if you need to, is 0. Sine power 2 is 1. 0 times anything is 0. Cosine times 1 is cosine. So I would get cosine x for my answer, but I need to do the reciprocal of that. Reciprocal of cosine will be 1 over cosine, which everybody knows is secant. And number 5, cotangent of x minus 2. So I'm looking for the I'm going to do tangent and then put my answer at the end. So I'm going to have tangent of x minus pi over 2. Just going to follow the identity right here. It's tangent minus. I'm going to do tangent of x minus tangent of pi over 2 over 1 plus tangent x tangent pi over 2. All right, let's just work through this thing. Tangent of pi over 2, remember, tangent is sine over cosine. If I'm thinking about pi over 2, I'm in a circle, I'm thinking up there, y over x would be undefined. So it's really tangent x minus something that's undefined. I'm just going to put that. 1 plus tangent x times something that's undefined. So that just leaves me tangent right here. But that's what tangent was. I need cotangent, so I'm going to do the reciprocal of tangent. Everybody knows reciprocal of tangent is cotangent, and that's where you end up. Number 6, simplify. First of all, there's a square, so I'm thinking square, multiply double square. So that's where I'm going. I'm going to square sine. I'm going to multiply these together, which would be sine x, cosine x. Double it, put a 2 in the front, and then square the second, which is going to be cosine squared. Now, because I see sine squared and cosine squared, all right, we just got completely interrupted right there. I know you don't know this, but it's a long story. Let's finish up this problem here. Have a sine squared plus cosine squared, which is 1. So I'm going to end up here with 1 plus 2 sine x cosine x, and that's as much as you can simplify, and that's okay. Number 7, same thing, factor and simplify. 7 has a difference of squares. So I'm going to go sine squared x plus cosine squared x, and then sine squared x minus cosine squared x. And again, once I see this parentheses right there, sine squared plus cosine squared, that's really 1. So I'm going to do 1 times that, and 1 times anything is itself. So I'm going to end up with sine squared minus cosine squared x. Number 8. It says simplify, so I'm going to factor the numerator. And if you want to, this is another strategy you can use. If you want to, you can put, for a minute or two, just to substitute in, let's put x in for all the signs. So I'm putting x where I see a sign. I'm going to factor without the signs in there. We'll get x plus 1 on the top, and x plus 1 on the bottom. And what's going to happen, those x plus 1s cancel. It leaves me with an x plus 1, but don't forget what x was. X is really sine x, so sine x plus 1. So you may want to do that. Even on the last 2, 6 and 7, you can also do that if you want to. Number 9, use the sum of difference identities to evaluate cosine 15. Cosine 15 degrees, one way to write that is we could say that it is cosine of 45 degrees minus 30 degrees. And I'm just going to follow the identity there. So I'm looking at my identity page for the cosine of x minus y, and it says do cosine x, cosine y. Remember the 45 and the 30 is your x and y, plus sine x and sine y. And you're just going to plug in the values. Cosine 45 is square root 2 over 2, cosine 30 is square root 3 over 2, sine 45 is square root 2 over 2, sine 30 is 1/2. If I multiply the first two together, it gives me square root of 6 over 4. The second two gives me square root of 2 over 4. Make it one big fraction. Let's say square root of 6 plus square root of 2, all over 4. That's all I can do on that one. Number 10, this is going backwards. I'm looking for a pattern here. It goes cosine, cosine plus sine, sine. So I'm looking at my sheet. Where's cosine, cosine plus sine, sine? It is this one. It's cosine x minus y. Well, that's my x. That's my y. So if I do cosine 83 minus 53, that's 30. And everybody knows cosine 30 degrees is square root of 3 over 2. That's a 2 on the bottom right there. Some review stuff here. Number 11, 12, determine the amplitude and sketch the graph of one period. Amplitude, period, phase shift. So this one, the amplitude is 1. The period is 2 pi divided by 4, which is pi over 2. There is no phase shift. So if I'm going to graph one period of that one, I'm going to go, maybe you start the graph at your phase shift, which is 0. Your period is where you end up, pi over 2. Halfway to pi over 2 is pi over 4. Amplitude is 1. Negative 1, cosine. Cosine starts at 1, it goes down, up. So the graph is just like that. Number 12, amplitude is 2, period is 2 pi divided by 1, is 2 pi. The phase shift is negative pi. Remember, it's opposite of C over B. Draw one period of that one. Remember what we do here, we start at the phase shift. The phase shift is negative pi. The 2 pi tells me how far to go. If I go 2 pi away from negative 1 pi, it puts me at positive 1 pi. Halfway between happens to be 0, which is good. That's my second tick. So there's my first tick and my third tick. Go up to 2, down to negative 2. Sine, remember sine starts at 0, goes up, down, up. So one period would just like that. Okay, 13 and 14. Tell the stuff that you don't have to graph. So the amplitude on this one's 3. The period, I would do 2 pi divided by b, which is 1/2. If I do 2 pi divided by 1/2, I'm going to do 2 pi times 2 over 1, which is 4 pi. Phase shift is the opposite of c over b, so pi over 2 over 1/2. Again, keep change flip. Cancel those, you get pi. 14. Amplitude is 2. Remember, it's always positive. Amplitude is always positive. Period 2 pi over 2, which is pi. Phase shift, opposite of c over b, pi over 2. 15. Fun stuff here. Prove the identity. Here we go, guys. Don't sit and stare. Do something. Okay. So first thing I'm looking at is let's do the math. Okay. Let's do this first. Let's change that secant to 1 over cosine squared. Okay. Now let's do the math. Let's distribute cosine squared times 1 is cosine squared. If I do cosine squared times 1 over cosine squared, they cancel. So I just get 1. Now I'm looking for negative sine squared, so I'm trying to get. So don't forget cosine squared plus sine squared is 1. And you can use all the variations of that. Cosine, which means cosine squared is really 1 minus sine squared. Minus 1, sorry about that. That was a mistake. That should have been a minus sign. I was wondering what was happening. This should be minus sign all along. The 1's cancel there. And it leaves me a negative sine squared, which is exactly what was happening. Sorry about that. I messed that sign up. 16, do the same thing. I'm going to take that left side. I'm going to change everything to sines and cosines first. I'm going to go 1 over cosine x, sine x times, and tangent sine over cosine. Simplify that second term right there. So I'm going to do sine times that, which is going to give me sine squared over cosine x. So they have the same denominator, which is cosine x, and I have 1 minus sine squared. And hopefully you remember 1 minus sine squared is always cosine squared over cosine x. And if you cancel those, you get cosine x, which is exactly what I wanted because that's what's up there. And the last one, 17. A lot of stuff on this one is like, again, let's just change everything. Tangent sine over cosine. Cotangent's cosine over sine. And cosecant's 1 over sine. Okay, that's a lot of stuff there. Fraction bar means divide. So I'm going to keep change flip. I'm going to keep the top. I'm going to go this way on this one. I'm going to keep the top here. I'm going to change this. I'm going to multiply the reciprocal because I'm flipping. Keep change flip of the bottom, which is sine x. So if I multiply by sine x, take this first term, I'm going to have sine squared over cosine x. If I do the second term, the sines would cancel and I would just get cosine x. All right, now I need to add those two and see what, because I'm trying to get secant somehow. So if I'm going to add two fractions together, I gotta have the LCD, which is cosine x. That first fraction already has cosine, so it's just sine squared. What does that need? It needs cosine. So you've got to multiply the top by cosine, which is cosine squared. Sine squared plus cosine squared, I love it when I see that. That's just 1 over cosine x. Guess what 1 over cosine x is? It's secant x, which is exactly what we need. All right, guys, hope that helps. Hope you make 100. See you tomorrow.